Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. This podcast addresses strategies to enable enterprise transformers and decision makers to understand how digital tools and techniques deliver superior results in the global competitive marketplace. My name is Thom Singer, and I have the honor to co-host this show with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Craig continues to serve the community of PLM as an advisor and a mentor. Every single week, Craig and I try to bring to this podcast interesting interviews and other ideas that are going to enhance the careers of all of our listeners. And today I want to welcome to the show, Rob Cooke. Hey, Rob, welcome to the Digital Enterprise Society podcast.
Hey, Tom. Hey, Craig. Great to be here. Thanks for having me on today.
Oh, we're looking forward to the discussion. You know, one of the things Rob is really passionate about is how to connect humans to data. He is the CTO and the founder of 3Forge that has offices in New York, Singapore, and London. And he is a lover of everything. I mean, everything about computers and computer science. And he constantly is thinking about how the computer works. So this is going to be a lot of fun. Craig, I hand it over to you to talk to Rob.
Hey, Rob, welcome to the show. So we've had a lot of discussions about PLM, product lifecycle management technologies, and a large part of where we came from was the mechanical computer-aided design world. But this point about data aggregation is really important. And I guess maybe let's just start out with a definition for our audience. What in these words, what do they mean when they're put together, and why is it so important today?
Well, I think the idea of data aggregation almost has a mathematical connotation to it, which is correct, which is, you're taking lots of disparate sets of data and you're trying to bring that up into a consumable set of data. So you might have millions, billions, trillions of records underneath. You're trying to aggregate that data up and then look at that to make meaning out of it. Now, that can be used in many ways. That can either be, humans want to basically go and look at aggregated data. Maybe they want to be able to drill down on that data. Maybe you want to be able to set up alerts or triggers that automatically fire based on the aggregated results of data. But really, the ability to aggregate data is a key part of data exploration.
Okay, so I can get how that might be powerful, but one of the things I stumbled across in my career was shall we just say sloppiness in terminology, where people use the same words, but they meant something semantically really different. Like I can remember the word program, and program in a big industrial company typically means money, right? So how much investment we needed. And if you talk to a plant manager, it was about changing the plan. If you talk to a chief engineer, it was about the product, right? And of course, they're sort of related, but the word program was never clear. And yet when you aggregated data, business data in this case, about programs, it got really confusing, right? So how do you deal with lack of clarity in your dictionary?
Sure. And program in this sense means, what are we going to talk about today, right? Like, what's the program?
Well, and then there's today's program. Yeah, that's right.
Yeah. So it is interesting. I think that people tend to have a worldview, and this is what makes the world an interesting place. You've got artists, you've got mathematicians, you've got engineers, scientists, etc., and they all have their own worldview and how they like to look at things. And they come up with certain common terms that really apply to what they're doing. I'll never forget, I've got to give an example. When we first hired someone, his father was a contractor. And I said, we're going to be doing a demo this afternoon. And he said, well, what are we demolishing?
Yeah, you meant show features. Yeah, okay.
And he was thinking ripping down a building. And I'm like, no. Demo as in demonstration, not as demolish. But it is true. My whole life, I had thought demo meant to demonstrate the product. And all of a sudden it occurred to me there's another meaning for that. But all this comes down to, actually, I think, one of the interesting things about data, and the more I've studied it and tried to find ways to make it convenient, the more I've gone back to the roots of, I think, the solutions and ideals in place in the 1970s. to be a bit ironic, which is you need to have a schema. And the more well-defined your schema is, and the more verbiage and documentation you put around that schema, the better you will be in the long run. The irony is, and the problem is, the less stringent your schema is, the easier it is to put data in. But the problem is it's harder to get data out, right? It's very easy to us to talk to each other and just use the word program. I can say that word to you and you can say that word to me, but until someone actually tries to know what it means, it doesn't matter, right? It's communication. There's a receiver and a sender. And so I think one of the problems about data and what this really boils down to is we tend to focus on the inserting of data and how can we make it easier to get data into systems. But that actually is a double-edged sword, because if you're only focused on that and not thinking about how do you get data out, then now you're stuck in this problem. Now, we've done huge amounts of work inside our platform to help people map, program to program to program and try to map these things up and put a layer on top of this. But at the end of the day, if I could give advice, it would be think about how you're putting data in and come up with these correct terms. Don't use the word program twice if you can avoid it.
So what's your best elevator speech for the executives that say, I don't want to spend the time translating data and getting to a schema? We computer scientists like that word, but a lot of other people just cringe when they hear that word, right? But the point is getting to some rigor in how we use language, which is in how we use data, right?
Yeah, well, the elevator pitch on this, and there's a few different components to the product. One of the big components that we focus on is what we call leave the data where it is, which it's an elevator pitch that works very well for the executives, but I still think it's better to do it right in the first place. So I might get thrown out of the elevator. However,
make sure it doesn't have a window. Okay.
I'm in the elevator. and I'm focused on helping companies where they're at now. I call it leave the data where it is, which is you basically, instead of trying to take, so I think there was this period of time, and it's still happening somewhat now, which is let's take all the data from our different systems and bring it all together and put it in a data lake, ocean, river, whatever sort of body of water you want to use. You take it all and you put it in one spot. And I think that actually has a lot of flaws, because now all you've done is transferred the problem. So you have the 5 different groups that all use the word program interchangeably. And now you're saying that whoever is building this data lake better understand all the different terms and come up with some sort of language that makes sense around all of that. The fact is that doesn't scale. It's actually not how human nature works either. The way I look at it is you would leave those systems where they are, and then you would build a substrate on top of it. You'd build a layer on top of it that basically allows you to map it according to how different groups want to see it.
Okay.
So, for example, Group A, and I'll struggle with program. I'll stick with this though. Group A is computer scientists. So when they see the word program, that's going to route to a certain meaning, right? When engineers see the word program, they're going to think a different thing. So that's going to route to something different. So you almost need this translation layer in the middle. And it actually saves you boatloads of money, because now you're not trying to take, suddenly the problem scales based on the size of the schema, not the size of the data.
Yeah.
Always better off doing that. Yeah.
For the mathematicians in the crowd, we just went from a quadratic expression to a linear expression, which is really good.
Bingo. Yes.
But then you can solve it quickly, right?
Exactly. Yes.
Yeah. Okay. So I think, I'm replaying my history. We went down that rabbit hole of trying to convert data to a common schema. And we always had some part of the organization resistant to change. Now, some of those people were just the recorders, right? They literally were making the reports for executives. Remember, I was a part of a big company. And so they had a good defense for why it just had to be their way, because, a particular executive wanted it a certain way, right? So those kinds of arguments took a while to take apart. And part of it, frankly, happened with retirements, meaning the big champion that really wanted it, once they were gone, all of a sudden it was really easier to fix it. So I guess where I'm going with my point is, what are your insights as you work with different companies? What helps people realize you can leave the data where it is, but you got to get past this, my way or the highway attitude that you get from some of the silos?
Right.
I got some tips for us on how to manage that? besides dynamite?
Well, the first piece of advice I'll give to your listeners, if the young listeners out there, is if you want a job for life, learn COBOL or Fortran.
Hey, I've actually programmed in both, and there are very few people that know what you just said.
Exactly, but I'm telling you, they're in high demand, and they are retiring, like you said. It's stuff like. But that's not. I know that wasn't really the root of the question, but I had to at least give that advice. I think that the argument is so. I'm coming from a fintech background, and it's manifested itself. The same things happen, but it's come from a different angle. Mm-hmm. Regulatory and compliance has been that voice. It must be done our way or the highway, because at the end of the day, you have to meet these regulatory requirements, and these regulatory requirements often cut across many different systems.
Right.
So the thing is, so what I've come down to, so the way it's been sold from regulatory and compliance is, look, we're going to build this consolidated database. And once we do that, first off, we're going to be able to answer all of our regulatory compliance needs. And the good news is it's going to make life simpler for everyone everywhere. The reality is it only ends up satisfying the regulatory compliance. Right. Maybe there's organizations out there that have been able to do better than what I'm about to say, but from what I've seen, basically a lot of money and time is spent consolidating all of this to meet the minimum needs necessary that the regulatory and compliance is going after. So in your case, when you're talking about executives that wanted to see reports, if I had to guess, at the end of the day, these consolidated systems did nothing but answer the questions those executives wanted to see.
Yeah, which in some cases became irrelevant. Exactly. I mean, the business passed them by. It didn't matter anymore, but the bureaucracy that we put in place to build it didn't know how to give up. Nobody told him the job was over.
Right. Well, that's the other amazing thing about data and data discovery is once you've done, and I'm going on a different topic here, but I think the fascinating thing is you spend all this time and all this money so you can do this data discovery. The problem is once you've done that data discovery, it's time to move on, actually. Now you want to ask deeper or different questions. You don't want to keep asking the same questions over and over again. The business is evolving. You've gotten the answers to your data discovery. Now you want to move to something else. So the idea of building and spending tons of time to answer these questions, it doesn't serve that great a purpose in the long run. I think you're better off, again, going back to leave the data where it is, basically do the translations, get the answers you need, and then use those answers to refine the system so you can ask better questions to get better answers, so on and so forth. Now, at the end of the day, if the executives need a certain report and the regulatory requirements, they need certain reports. Again, I go back to my translation layer. Those are views of the world. Those are ways of viewing information. And an example I could almost make, just so everyone would, I think it would for the general audience is, when you get on your navigation app and you're looking, they're taking a huge amount of information. The geolocation of all the different commercial establishments, the highway system, the traffic, et cetera, and then they're just taking what a particular perspective is, and they're letting you view that, right? And so I think there just needs a bit of humility that the idea that you're going to take all your data, put it all in one spot, and answer every question all at once isn't a reality. What is a reality is to say we're going to take all of our data from all of our different systems, build a mapping on top of that, and then provide perspectives on top of that for the different groups. That is something that works. It's just not, it doesn't quite fit the mental model. The mental model is all we got to do is get everything in one spot.
Well, and I, this is why we have it in the PLM domain. A lot of the PLM people said, and I'm talking about solution vendors, so I'll pick on them for a second. Product lifecycle management. If it's about the product, it should be in the lifecycle management tools. There's no debate. Just put it all in there. Your earlier point about a lot of things were created that favored the author, right? The people recording it or inputting it the first time, and not the user, which is this other perspective of viewers. And especially in this world where everything's changing, whether it's the health challenges we all have or the supply chain challenges, we want to have different views because all of a sudden a new constraint has come up and we want to examine a way to get around the constraint, whether it's the supply of parts or whether it's who's coming to work today because they're out ill. So I think different views in a flexible world where you got to change your processes because of outside constraints, I think having these views is really helpful. And I think that's maybe that's one thing we're going to keep emphasizing in this next year is the views matter and the flexibility of the views matter. The fact that you want to create a view on the fly as you're confronted with new decisions or new problems to make. You want all this data. You want it to be a lake. It's really a swamp, right? and that's part of the problem. The swamp is bubbling. It's producing gas, right? And some of it's the misnaming. But okay, so let's talk about another dimension of this. So there's the data that you authored with a human being, but then there's all this data coming from better and better sensing. Your example of a nav app, it used to be it was just the GPS receiver through the cell phone, but now it can also be whatever Apple's monitoring in your earbud and also your Fitbit. And oh, by the way, your car's got certain dynamics and diagnostics, and so it's feeding back data. When you combine those together, you get some interesting insights, right? Like, why did the speed go down but the heart rate went up? Well, because there's a stupid thing going on the road, right? All of a sudden it goes from green to red on the Google Maps, right? These things are all connected. That's what you guys are doing. But the view, to your point, is tailored to what's the important information I want to know, right? So it's interesting. So has IoT, has this massive connection of sensors made the problem easier or harder, this aggregation of data?
The answer is yes. It has made it easier.
Because very good answer. Because I think what's easier is that people see the value in it, right? They get it, and then they turn to you and say, "Make it happen. Make it so. Happen. Make it make it happen."
Exactly. So stepping back a little bit, we've basically, as Tom mentioned at the top. I really spent my whole life thinking about computer science and especially data and how humans look at data. And I've actually broken it into 3 buckets. And I need to kind of go through this so that I can answer it in 3 different parts. The first one I'll skip over. I'm not going to spend a lot of time. We'll call it data entry, which really is, it could be like you're wearing the device and it's telling you the heart rate, something like that. But that's not too important for this, but I've got to at least highlight it as an item. So you've got the actual input of data. And then the second 2, I think, are the very important for this conversation. The ability to ask questions of your data and get answers back, which I think is what we've been talking about a lot at the beginning. And then the other one is the real-time streaming of data, which is as data is being generated, being able to evaluate that in real time. And so to talk about data analysis, you almost, I think in the beginning, you have to divide it into these 2 buckets. You either have to think of it as, the reason I say to think of it in these 2 buckets is because the computer science, the literal computer science approach you take is quite different between the 2. To use a technical term, it's online versus offline computing. Mm-hmm. But in this case, when I mean online, I mean as data is streaming in, you're evaluating it as quickly as possible to make decisions. When I say offline, I mean you've got a huge set of data out there. You want to walk through that data and then use that retrospectively to help you make decisions. So now let's go back to your question about the various sensors on yourself.
Yeah, so, and there's more and more coming, right? You can't stop them. They're here.
Yeah, exactly. So from our implementation standpoint, there's 2 ways that we have to look at that. One is, as the data is taking place, we need to be able to process what's important as quickly as possible to help you get updates. So that is looking at the GPS sensor, understanding your latitude, longitude, etc., being able to, in your example, understand your pulse and your heart rate and everything like that, and being able to quickly strip away what isn't important and focus on what is important to give you timely information. That's the online part of it, and that is a complete field that I could talk about how we look at that. The second part of this is all that data gets stored and sent somewhere where now you can start to look at that retrospectively to analyze that and then make predictions about what's going to happen later on. And those 2 things are very different. The second one that I was talking about with the ability to basically store that data and analyze it, I think that's where the leave the data where it is becomes very important. And I also think that the ability to do drill downs and to be able to modify and change the sort of data discovery you're making becomes very important. And I could give an example, which is, maybe we go back and we have this theory, which is, well, if the cars slow down and the heart rate goes up, then that means there's a traffic accident. And so we run that analysis on historical data, look at it. We're either correct or we're incorrect. But once we know whether we're correct or incorrect, we can kind of move on to something new. So it's the ability to basically be able to ask questions of this historical data, make hypotheses, and then draw conclusions and use that to ask additional questions. All of this sitting in parallel with, I think, machine learning, which is becoming a very important part of this as well, which is, you kind of throw the data at it, you come up with models, and then you allow that data to train the models. But again, that's a historical thing where you're using that to train models, and then those models are used to help you as real-time data is coming in to process that. So there's a lot to say here. Hopefully,
And so back to our data clarity point. Does that screw up the training of the models? If it's a swamp and not a lake where it's well behaved, then when you do all this machine learning on it, can it lead you astray? Is that one of the risks?
Yes. So I have always talked about, I came up with this a few years ago, the 4 V's. And the 4 V's of data is validity, variety, volume, and velocity.
Oh, interesting.
And those are the 4 things I've thought about. So I'll go through each one of them in terms. Velocity, that's just data. That's just the speed that data is coming at you.
Which is what IoT is just making it explode.
It
right?
is.
We
yes.
used to think it was expensive to sense. Now it's cheap to sense, right?
Exactly. Right. And so it's shifted the problem. I love it. Every time you solve a problem, it creates a new one, which is makes engineering so much fun. So velocity, yes, IoT has increased the velocity and volume tremendously. And probably volume even more so, right? So the amount of data has gone up, but so has the speed of the data. It's kind of like amps and volts, Yeah. So volume and velocity. And then the other 2, I think these are the interesting ones and the more challenging ones, which is the variety and the validity. Because the variety of data goes up. Again, going back to your example, you've got your GPS system, which is giving you updates dozens of times a second. And then you've got your heart rate monitor, which frankly can be wrong sometimes. You can look at it over a period of time. So the variety there is quite a bit different in how you want to handle that. So that needs to be normalized. And then you've also got the validity of the data. Sometimes your GPS is wrong. And, imagine if the moment your GPS, for whatever reason, captured the satellite data wrong for a very short period of time, and then your car veered off the road, that would not be a good thing. So, we have to, so validity and variety become very important as well. But anyways, I'll go back to those 4 V's. I think, each one of those needs its own bit of respect in order to tackle this.
So I like your 4 V's. Can they help each other? And here's an example. So validity, anything going through the airwaves can be affected by electromagnetic waves. Every now and then we get a pulse of electromagnetic waves that are more intense than typical from the sun or from wherever, right? Can volume and validity help? I said it wrong. Can volume and velocity help validity? I mean, can they give you confidence that one of the V's is better when you get more of the other V's?
Oh, absolutely. Yes, I would totally say that. And I would say that even more so when you're starting to look at historical data, because once you have a large set of data, you can start to do like nth percentile sort of things, like, just drop the bottom 3% that's off by a certain factor. Just don't pay attention to that. It's harder to do that when the volumes of data are smaller. So as the volumes of data grow, it makes it easier to kind of build those histograms and chop off the edges and focus on the meat of the problem. So I think the volume and velocity, having those there definitely, in fact, I could flip it around. I don't think if you didn't have the volume of data, it would be very hard to confirm the validity of it.
Yeah. Well, what's interesting in this discussion, if there's any quality engineers out there, the guys that look at mass production quality, right? They're like, yeah, that's our basic cookbook. That's what we do. And the problem with that, if you're a quality worrisome guy, the chief engineer, you're like, yeah, but until I get the volume, until I get 100,000 built, I don't know if I got a problem, right? Well, this is where I think another dimension of computers can come in. We can simulate, we can sense 10, and we could simulate the other 90 based on our historic. I like your point about going back to history, and then just ask the question, a hypothetical question. Well, what's the risk of there being a failure here, right? With the recent failures in the car business, and including the one that maybe was the most expensive, which was the airbag one. At the end of the day, it ended up being location in the country and humidity, and then a manufacturing flaw. If you used it in the right part of the world, it never would fail. And it's just bizarre that those things were connected. Well, until they had enough volume, like 3 years of volume, they couldn't really tell this was going on. I'm imagining in our new world, use the 4 Vs and use part of the volume coming from simulation, a virtual world. I don't want to say meta, that's going too far, but a virtual world. Then we can say, well, your risk is higher today than it was tomorrow. We'll keep monitoring. And oh, by the way, maybe you want to put out a restriction. I think this is starting on batteries. From what I can tell with electric vehicle batteries, the really smart data scientists and the engineers are trying this exact kind of an idea, right? Can we better assess risk based upon some of it's synthesized? It's simulation. It's based on physics, and history, but it's not really sensed yet, right? The old quality guy, he's treating everything like a random process, and he's waiting for samples to come from the field that exhibit the problem. So, Can simulation help?
So first off, the reason I like so I'm going to give you my best answer from a different vantage point. But the reason I like doing these podcasts is that I think the way that everyone grows, the listeners, the hosts, is by taking perspectives from different industries and seeing what makes sense and how things work. So I do look at finance, which is really a bulk of our customers are in that. In finance, I do look at finance as, it's been around a very long time. It's dealt with huge volumes of data, et cetera, et cetera. And so I will say this: back testing, which is the term we would use for what you're talking about, is absolutely critical. There is no replacement. So back testing is the idea that we've got a huge set of data from the past, right? We got data from 2000 to 2020, let's say, of the market. And then the idea is you put together a hypothesis that says if the market does X, Y, and Z, then it will do this other thing. And so you come up with that hypothesis and you run the back test and you see if the result is there. Now, this is the irony with finance is because it's a feedback system, once you've solved that, you can make a boatload of money. But then the problem is you now put that into practice and now you're actually changing the environment and you're ended up breaking your back test.
There's some principle there about affecting the experiment, but whatever.
Exactly. But we'll put that aside because at the point is in the case of the airbags, solving the airbags isn't going to create a new problem. But having that back testing in place where you say, look, we've got this huge set of data, let's simulate these things and see what the output looks like. That's first off, it lets you in a much more cost-effective way and without putting lives at risk, frankly, be able to run a lot of different scenarios. So I think what's interesting, especially as cars, because we're talking about automotive right now, have so many sensors, so much data is being collected, and especially if you look like a Tesla car, which by the way we've worked with those, they're producing huge amounts of data. I mean, you can connect right to their main boards, pull that data off, collect it. We've done it to huge amounts of cars, and you can start to look at that information. We've tied that with weather sensory data, and then you can run these tests and start to see how they react to changing weather. Actually, now they've just come out with that in the recent releases of the Tesla. They now bake that in. But the point is, you basically can connect and get all of this data, and then you look at your surrounding data, and then you can run these tests and simulations to see what's going to happen in scenarios, and it makes it that much more, in a simple scenario, in a simple example, it makes it much easier to anticipate when you're going to run out of electricity in your electric vehicle, because now you know weather conditions.
Or in the electric grid where you can't charge it anymore, but never mind, that's a whole nother problem. Okay, so my last question, look in your fuzzy crystal ball. What do you see coming next? I mean, we got lots of data. We got it cheaper and cheaper where people like you are figuring out how to leave the data where it belongs and still aggregate it so you can make better views. What's going to happen next? say in the next 3 years? It's been fascinating to me what computers can do. What are we going to do next?
Right. Well, it's hard to say 3 years, but I can say.
Or 1 year is fine.
I was going to say in the next 10 years, I think.
Oh, okay, do that.
I'll go the other direction. Yeah. Well, so this is kind of the trajectory I've drawn, and I've really spent a lot of time studying the history of computers and how we've gotten to where we are. And I've always looked at it as the real disruptors. And this might not be the term that people use today, but I use the word disruptor for things like when we moved from physical computers where you literally were soldering things together to when we had to when you could actually use software in the logic instead of having physical logic. And then we moved to compilers, and then we moved to operating systems, and then we moved to databases. To me, those are layers that we've kind of built on top out of necessity. And every time we've solved one of those layers, it's allowed us to move to the next generation of computing. Let's put it this way. Today, there's not a whole lot of computer scientists out there thinking about how they're going to read and write data from a file system. Usually that's done by databases. Maybe it's
at the library. They go get it from a library.
Exactly. So these layers have been written. But I think that the next layer, the next thing that needs to be focused on really is layers that are aware of data systems and the data that's available, how to connect to all those different systems, and then basically be able to run analysis on that data and feed that data back in. So that's what 3Forge is focused on, is trying to build one of those layers. And I happily welcome today that we have a few competitors out there that are basically also saying, look, are you a 3Forge or using this or using that? And depending on whatever platform you're using, that's your go-to for how you connect to lots of different systems, bring that data in, run analysis on it, and do data entry. So that's my prediction, is that this layer, and we're hearing terms like low code, no code is coming out, which I don't necessarily love that terminology. But at the end of the day, I think that concept of starting to build these layers where people are no longer thinking about individual widgets and individual like GUI components and how do I write lots of code so I can connect to this particular system. We need to move to the next layer. And I think there's a lot of smart people focused on that.
Yeah, the only reason the no-code thing is there is because those solution vendors used to charge the OEMs a lot of money for the code.
Exactly.
Now they're trying to say, building the app is really easy. In fact, anybody can do it, and some of that's true, by the way. But it'll get better.
It depends on the use case. It depends on the use case. But yes, yeah.
So, Rob, this has been wonderful. We've almost used up our time. Tom, you've got any other questions?
No, we have used up our time. So Rob, if somebody wants to find out more about you or about 3Forge, where should they go?
So our LinkedIn is really our main social media outpost. So if you go to 3Forge on LinkedIn, that's where you can find out about all the updates. We've connected to over 100 different databases. We're constantly giving reports on how we view the different databases, what they're good at, what they're not so good at. Also updates to the platform, etc. So that's really the place to go. Also 3forge.com. That's our landing page where you can find out information about us and the product.
Nice. Well, again, thank you for being here. And thank you to everybody who tuned in and listened to the Digital Enterprise Society podcast. Learn more about what you've heard today at digitalenterprisesociety.org. We encourage you to leave us a comment in the show notes or wherever you get your podcast joy. You can leave comments at Spotify, at Apple, etc. And then make sure that you come back every single week for more conversations about organizational transformation through the use of digital tools and techniques. Go find out more about us at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.